Okay, this is the Unit 3 Lesson 4 video. We're in Chapter 7, Section 4 in the textbook, and we're talking about solving logarithmic equations and inequalities. There are content standards that we're going to look at in this lesson are using the structure of an expression to identify ways to rewrite it, and creating equations and inequalities in one variable and using them to solve problems. Our mathematical practice that we're going to be focusing on is modeling with mathematics. So back in Lesson 3, we evaluated logarithmic expressions, and in this lesson we're going to solve logarithmic equations and solve logarithmic inequalities. So we talked about logarithms last time, so logarithmic equation should be fairly obvious. It's an equation that has a logarithm in it, and same type of thing with inequality. So our first equation says log base 8 of x equals 4/3. So thinking back to our lesson, lesson 3, we need to realize that this is equivalent to saying 8 to the 4/3 power is equal to x. And there's a couple ways of thinking about doing this problem. One of the ways they show on the screen is to remember that 8 is 2 to the 3rd power, and then you have 2 to the 3rd to the 4/3, and then you would just multiply these exponents. And 3 times 4/3 is just the number 4. 2 to the 4th is 16, so x is 16. Another way of thinking about this is, I'll try to write this over here on the screen on the side, up here, that 8 to the 4/3 is the same thing as 8 to the 1/3 times 4. And if that's true, then what we can do is do 8 to the 1/3 and do that in parentheses, do that first, and then raise it to the 4th power. And 8 to the 1/3 is just the 3rd root of 8, or the cube root of 8, which is 2. And that's 2 to the 4th power again, which is 16 down here. So if you prefer the way that they show on the screen, go ahead and do it that way. That's perfectly fine. For me personally, I prefer doing these problems the way that I wrote up here. But whichever way you prefer, go ahead and try that way, and you'll get the same answer either way. Okay, let's look at a check your progress problem. We've got log base 27 of n equals 2/3. And our answer for this one is C, n equals 9. Okay, we've got a key concept, the property of equality for logarithmic functions. This says if log, here I'm just going to read the example, not the symbols, because the symbols tend to be kind of confusing. But it says if log base 5 of x equals log base 5 of 8, then obviously x has to be 8, since they have the same log and the same base, so x has to be equal to 8. And similarly, another way of saying this is if x is 8, then log base 5 of x equals log base 5 of 8. Or you could say log base 2 of x equals log base 2 of 8, or log base 1,000 of x equals log base 1,000 of 8. As long as the logs and the bases match, then these two expressions have to be equal to each other. So for example 2, we're looking at essentially a standardized test, a multiple choice question, which says that log base 4 of x squared equals log base 4 of negative 6x minus 8. So because we see that the logs and the bases are the same, we can just take the expressions x squared and negative 6x minus 8 and set them equal to each other. So when we do that, we create the equation, I got ahead of them a little bit, x squared equals negative 6x minus 8. And what we're going to want to do is bring everything to one side of the equation. So we're bringing everything to the left side. We're going to factor this. We see that our two answers would be negative 4 and negative 2. And so then on our next screen, we'll see which choice that was. They want us to check your work. It's always a good idea to check your work. If you plug back in negative 4 squared is 16, log base 4 of 16. If you plug in negative 4 in on the right side, negative 6 times negative 4 is negative 24. Negative 24 minus 8, or sorry, this is positive 24. Negative times negative is positive. Oops. 24 minus 8 is 16. We see that the numbers match, so obviously the equations are true. And similarly, when you plug in negative 2, you get the two sides are equal, so that both of those answers check out. And so therefore our answer was choice C. Both of the solutions to negative 4 and negative 2 are the correct answer. Okay, we're checking our progress. Similar kind of concept here. We've got log base 4 of x squared equals log base 4 of x plus 20. And solving that, we see that our answers are going to be A, 5, and negative 4. All right, we're jumping into inequalities now. And it says that if b is greater than 1 and x is greater than 0, and log base b of x is greater than y, then x is greater than b to the y power. Basically the same expressions as before, but changing the equal signs into inequality signs. So we have one equation, one property for greater thans, and one property for less thans. Notice that x in the less than side, if log base b of x is less than y, that x is less than b to the y, but x is still always going to be greater than 0. X can never be negative when you're dealing with log functions. So solving log base 6 of x greater than 3. First we're going to put that in exponential form, which says 6 to the third power. X is greater than 6 to the third power. So x has to be greater than 216, and then you would just graph that solution on a number line by having an open circle at 216 and putting an arrow to the right since we're greater than. Our solution for this one, check your progress, we have log base 3 of x less than 2, which is just going to tell us that x is less than what? And we see our answer now is choice B. 3 to the second power is 9. So x has to be less than 9, but remember x is still always going to be greater than 0. It's important to say x greater than 0 still in this kind of inequality. All right, another property, we're looking at this right here. If we have log base b of x greater than log base b of y, that's true if and only if x is greater than y. And log base b of x less than log base b of y, if and only if x is less than y. So for example, if we have log base 6 of x and log base 6 of 35, if the x is greater than 35, like if the log of x is greater than the log of 35, then x has to be greater than 35 as well. So example 4, applying that concept, log base 7 of 2x plus 8 greater than log base 7 of x plus 5, that means that 2x plus 8 has to be greater than x plus 5. So we're going to set up that inequality. We're going to solve for x. We get x is greater than negative 3. And on the next screen, that's going to tell us that our solution is all x values greater than negative 3. Right here. Okay, check your progress problem. Similar concept here. Moving on to the next screen, we find that our answer is choice A, all x values greater than 4. This was a real quick lesson. This is the end of Unit 3, Lesson 4 on solving logarithmic equations and inequalities.